as the name indicates, you can see that some of the drawbacks which we found with the previous microscopes, we can overcome over this, because you can see that the previous one, if you look at the XRD, the XRD and all these will be very much applicable only the crystalline materials, only for the crystalline materials, which will be very much useful. But here in this case, including the glass, the composites, biological samples and ceramics, polymers, all these can be viewed through this, and we can able to get the image of whatever we require. That is one of the very much important advantage of using this atomic force microscopy. The atomic force microscopy, which will be having a laser which will be falling onto the sample surface. The sample surface, it will be having the tip. It is also having the tip. The tip will be sensitive between 10 to 20 microns. And the photo which is falling onto this sample surface, okay, and the probe will be just moving onto this in the defined area, and here we can able to find out the error also. The photodiode and the sample informations which you have collected, the detector and feedback electronics. That means to show these two will be giving both are giving the readings, and we can able to find out any errors are incurred in these systems. We can able to find out. Okay, and so far whatever we have studied, the electron beam microscope and all this atomic force microscopy, which can able to give you the information about the third dimension also. Okay, one thing. And using this, one of the important advantages is that we need not to go for the preparation of a specimen. The specimen need not to be treated for the opaque surface and all this. Okay, it is one of the important advantage of using this, the atomic force microscopy. And the other one important thing, in other cases, the electrons, while they are directed through many sources of lens and the collimator, what happens there? It has to be moved through the vacuum. It was necessarily moved through the vacuum, but here in this case the vacuum is not required. Even the ambient temperature, ambient air, it can able to work on. That is one of the important other advantage. And here, as I told you, the working table around 150 by 150 microns dimensions. It can able to give the maximum reading range between 10 to 20 microns. It can able to give. That means to say, we can able to view the sample of 150 by 150 micrometer, and 10 to 20 micrometer image can be captured. Okay, and it is highly dependent on the probes. As I shown here, it is very sensitive probe will be there. It will be the whatever the readings we are going to get. This is the sample, and on the sample it is going to give you the information about the dimensions of the atoms and all this. So the probe sensitivity is one of the important thing here. Okay, if the probe lost the accuracy, we have to go for the recalibration. It will be costlier method. Okay, and another one, the errors may be incurred due to the interaction. That means the human error, chaotic errors we say. Due to these errors also, some errors may be magnified. These are some of the important things which we need to remember. So atomic force microscopy. So whatever the drawbacks we had in the previous all kind of microscopes, we can overcome, and here the additional third dimensional information also we can able to get. The sensitivity of the output dimension or output readings will be totally depend on the tip or the probe of the atomic force microscope. Okay, and another one thing, the surface need not to be treated. It is not required to treat the surface for the or prepare the surface for the sample preparation. Sampling preparation is not required. Okay, and another important thing, we can able to even test any type of glasses, ceramics, and all these. It is not only for the crystalline materials. Okay, these are the some of the advantages. At the same time, some limitations are, and the disadvantages are. It is highly dependent on the total reading, whatever the accuracy we are going to incur. Those will be totally depend on the probe sensitivity. Okay, and errors may be due to handling also. These are the some of the important things. And electron probe micro analyzer. Electron probe micro analyzer. See all the so many microscopes we have studied so far. All I wanted you to remember them. Atomic force microscope and the scanning probe microscope and XRD. XRD is for the crystals and it follows the Bragg's law. Okay, and another one, the electron beam microscope. Okay, electron beam microscope and TEM. TEM. The TEM also you have to remember. Its working principle, transmission electron microscope. Okay, and another one SEM, scanning electron microscope. And another one important one is the chemical vapor condensation process. Okay, and all these you have to remember. So my job has become very simple to show you. You need to go through all these and prepare yourself for the examination point of view. Okay. Now let me come to the electron probe microanalyzer. Electron probe microanalyzer. Here, the bombarding of micro volume sample with the electron beam, which will be giving you the essential information of the specimen. Okay, essential informations of the specimen. And how it works, we can see that the electron source or source of electrons, which will be emitted from the cathode, it will be attracted by the anode, and you can see that there will be series of lens and the condenser glasses and the collimators will be used in order to direct and redirect the electrons. Okay, and WDS is wavelength dispersive spectroscopy. Wavelength dispersive spectroscopy, and which will be giving you almost all the informations whatever we require. Okay, and the specimen will be kept here. The specimen will be kept here, and we can able to get the information of diffracting crystals to get them. Okay, and another one important thing in here is that the X-ray, which are here also the same thing. The electron source, whatever the electrons which are emitted, those will be bombarding with the anode here, and at this anode, due to the collision, the X-ray will be generated, and all these X-rays. Hello.
Sir, Sanket is waiting in lobby, sir.
Okay. Okay. And whatever the electrons which are bombarded on the anode will not be converted into X-rays. Here also, around 1 to 2% of the electrons will be giving you the X-rays. Remaining all will be generating the heat. Here also. Okay. And here you need to remember another one thing: the wavelength dispersive spectroscopy. The wavelength dispersive spectroscopy, which will be giving you almost all the informations of the and the characters of the items and any impurities present in the sample. All these can be obtained because since it is a very WDS, it is very sensitive and it is very sophisticated visible light source. It is actually okay. And what happens? It also follows the Bragg's law. The Bragg's law, you know that already. The Bragg's law in the XRD we understood. The Bragg's law, what it says. So any point of the interaction on the layer or a surface of spectrum, what happens? The light will be reflected back. So you remember this: n lambda is equal to 2d sin theta. N is the layer which we have considered. Lambda is the wavelength, and d is the distance between the layers in the spectrum. Okay, based on this, we can able to it is also working on the principle of the Bragg's law. Which one? WDS, that is the electron beam microanalyzer. And here also you can use it. The electron beam microanalyzer. This is totally, this particular cabin belongs to the electrons or X-ray emission for the analysis purpose. And here the series of deflectors and the colorimeter and the glasses will be used, lenses will be used in order to direct and redirect the electron beam which are emitted from the cathode. Okay, and at this point of interaction, what if the specimen will be kept here and it will be magnified, and it will the wavelength, based on the wavelength it will be working. So due to this wavelength, what happens, the light will be dispersed and it will be giving a spectrum output. A spectrum of output it will be giving you in the magnified form, and it can be used for the analysis purpose. Okay, and any doubts are there, please ask me in this. Its major applications I'll be discussing, and after this we can have the discussion. Geochemistry we can use it, and mineralogy we can use it, geochronology we can use it, and physical metallurgy and nuclear metallurgy, material science. That is what we are going to discuss with, including glasses, ceramics, and semiconductors, cement, microelectrons, and biochemistry. In all these, it has opened its widespread wing in order to find the microorganisms. Also, we can. It has found it's a very sensitive. The output, the spectrum of output, it will be giving the enormous information about the inner qualities of the systems. Okay, and the next, any doubts are there? Please let me know it in this.